Hi everybody, this is Eduardo Suarez. This video is part 4 of a series of videos dedicated to iRPickTool with a pre-grouping and option package. In this video, we're going to continue with the configuration of iRPickTool. If we go to the setup diagram, we're very close to the end of the configuration. In this video, we're going to continue setting the reference position for the sensor on the in-feed conveyor, setting the target position for the sensor on the out-feed conveyor, and teaching the position for the robots on the in-feed and in the out-feed conveyor. Once we have this setup complete, we're going to be able to run and test the application. We're going to go to the work cell, and the first thing that we're going to do, we're going to change the user tool to user tool number 1 on both robots. We're going to select robot 1. We're going to open the teach pendant. We're going to press Shift and coordinates. We're going to select the tool and we're going to change it to tool number 1. Now we're going to do the same on the robot controller number 2. You're going to see that we have the suction cap in robot 1 and also we have the suction cap on robot 2. We're going to make sure that we have the part located on the in-feed conveyor. We're going to select robot 1 and we're going to press Internet Explorer. We're going to select the iRPickTool setup. And you're going to notice in here that the only thing where we have a red check mark is on the sensor 1 and on the sensor 2. We're going to select the in-feed sensor 1. We're going to verify in here that the control is robot 1, the trigger condition is system, the trigger action is find part by vision. We have set also the trigger distance, and the vision process is the single view visual tracking. And what we're going to do in here is training the reference position. For that, we're going to press Set Reference Position. We're going to follow the guide. It says, please put the target in the field of view, press Find when ready. We have already the part on the field of view. So we're going to press Find. It found the position of the part. Now we're going to press Next. After you press Finish, jog the conveyor so that the target comes in front on the most upstream robot, which is closest to the sensor, and teach a robot position in the TP program from that robot in order. So we're going to press Finish. The reference position is trained. We have a green check mark on the sensor. We're going to go to the work cell, and now we are going to jog the in-feed conveyor until the part is inside the working envelope for robot number 1. With robot number 1 selected, we're going to make the work envelope visible. We're going to select the control for the in-feed conveyor. And we're going to jog it. We're going to touch the part with the robot. We are touching the part on the center. We're going to open the teach pendant. We're going to split the screens. We are in robot controller number 1. We're going to look for this program. It's called PK_CV_ pick 11. One tip in here, if you have many programs, you can press on type and just select the program that you're looking for. For example, you can look for pk underscore, or you can look for just pk. This is like a filter that you can use for searching for your programs. We're going to press enter, and we're going to go to line number 70. Over here, we're going to touch up this point. We're going to press shift and touch up. It says the vision register number 1 is uninitialized. Continue. We're going to press yes. And the position hub is recording to position register 57. What we need to do now, we need to write down this position and put it in the robot number 2. We're going to select data, position register, and we're going to write down this value. Now we're going to select robot 2. We're going to go to data, position register. We're going to select position, and we're going to enter the same data. And we're going to press done. If you go to the diagram, we had set the reference position for the sensor, and we set the position register 57 on robot 1 and robot 2. Now we need to set the target position on the sensor on the outfit conveyor. We're going to go to the work cell. This time we need to open the iRPickTool setup screen from robot number 2. And that's because robot number 2 is the robot closest to the sensor. We're going to select robot number 2. It's saying that we are logging to robot number 1. We're going to select the outfit and sensor 2. We're going to verify this data. Controller is going to be robot 2. Trigger condition is going to be distance. Trigger action is going to be put parent queue. And trigger distance, we're going to keep it in 100 millimeters. This time we're going to train the target position and the reference position together. We're going to press set target position. We're going to follow the guide. It says please put the target on the conveyor upstream where you want to generate the target. We're going to go to the work cell, and we're going to change the calibration grid with the part. We're going to select the outfit conveyor, part carrier outfit. We're going to select parts tab. We're going to make the calibration grid invisible, and we're going to select the 4 batteries together. We're going to go to the setup screen, and we're going to press set trigger. Now we just need to jog the conveyor so that the part comes in front of the robot. With robot 2 selected, we're going to make the working envelope visible. This time we're going to jog the outfit conveyor. The best way to teach this position is going to be picking up the 4 parts together with robot number 2 for the infeed conveyor, and setting the position on the outfit conveyor with the 4 parts together. For that, we're going to make the parts visible on the user tool. We're going to set the position for the 4 parts on the gripper, and we're going to press OK. We're going to attach the parts with the TCP. We're going to go to the setup screen, and we're going to press next and record. Now we have the dot position and the calculated position. We're going to press finish. Now we have the target position train and the reference position train on the sensor number 2 on the outfit conveyor. We're going to go to the work cell. We're going to open the teach pendant. We're going to press select. We're going to look for the program pk_cb drop 11. We're going to press enter. We're going to go to line 69. And we're going to attach the position register 59. We're going to press shift and touch up. And again, we press yes. And with this, we have the position recorded for the position register 59. Now we have a green check mark in all the objects, and we have finished setting up the iRPickTool. The next thing that we can do is running and testing the application. If we go to the setup diagram, what we just did is setting the sensor target position on the outfit conveyor and setting the position register 59 on robot number 2. We need to do one more thing. We need to teach the home position for the robots. For that, my home position is going to be the 0 for the joints. We can do that if we select robot 1. We select the triad. You're going to see here the option for joint, and just put the values to 0. The other option would be, if you open the teach pendant, you select positioning here, you select join, and just put the value to 0 over here. And you can select the home position that you want. We're going to select pk_main1. We're going to go to pk_perch1. We're going to press enter. We're going to put in step mode. And what we need to do, we need to touch up position number 1 on line 15. And we're going to press shift and touch up. And with this, we have the home position for robot number 1. And we need to do the same for robot number 2. Now we're ready to run, and we're going to test the application, see that it works. We're going to select the infeed conveyor, part carrier infeed. We're going to select the conveyor tab. We're going to select 80 parts per minute, and we're going to put the speed of the conveyor to 200 millimeters per second. On the outfit conveyor, since we are picking up 4 parts at a time, it's going to be 20 parts per minute, and we're going to keep the same speed for the conveyor. Also, I did another adjustment. If we go to gripper number 1, I put in here a peak delay and a place delay of 100 milliseconds. That's going to help us to see the part when it's picking and placing, and the same on gripper number 2. Also, you're going to see that we have the part visible on the suction cap. That's going to also help us to see the part when it's picking and placing. We're going to open the teach pendant, and we're going to select the program PK main1 on both robots, and we're going to put the teach pendant in off mode. We're going to press cycle start. What you see here, the first part is going to be the base part. This is where the robot's going to start forming the virtual tray. So it's not going to pick that part, it's going to let it go, and it's going to start picking from the second part. You see here that's creating the virtual tray. It places the part number 4 over here, and now robot number 2 is going to pick up the virtual tray that is going to be over here on the base part. I'm just following the part with the mouse. And then it's placing the part on the outfit conveyor. You're going to notice that for robot number 2, there is an offset picking up the parts. It's not in the right place. We're going to fix that. But the pre-grouping robot is doing his job. We're going to stop the simulation for now, and we're going to make some adjustments. We're going to fix the non-pre-grouping robot. We're going to select robot number 2. We're going to go to tooling. We're going to select user tool number 1. We're going to go to properties, and we're going to select the uTool tab. On the uTool tab, what I did, I changed the location for the user tool on the Y. So this new location makes reference to cell number 1 on the virtual tray. We're going to press apply and OK. We're going to go to the iRPickTool setup screen. We're going to select gripper 2, zone 2, and we're going to update the position of the user tool number 1 over here. Now we're going to select tray 1. We're going to select layer number 2, and we're going to put the position of cell number 5 to 0. One more thing that I did, if we look at the sensor on the outfit conveyor, I changed the trigger distance to 600 millimeters. I came up with this value, 200 millimeters per second, that's the speed of the conveyor, divided by 20 parts per minute, and multiply by 16 to convert seconds to minutes. And that's going to give us 600 millimeters. We're going to make one more change. We're going to select the infeed conveyor, part carrier infeed. We're going to go to the simulation tab, and we're going to put an offset on the Y and in the rotation. This is going to be a random offset during the simulation. We're going to press apply and OK. And we're going to run again. Here we have the application running again and running in slow motion to be able to see the parts. You're going to see that the pre-grouping robot is forming the virtual tray. We are following along the virtual tray with a rectangle, and the non-pre-grouping robot is going to pick up the virtual tray, and it doesn't matter the position or orientation of the virtual tray. The non-pre-grouping robot is able to pick up the tray in the right position and orientation. Now I'm going to speed it up and let it run a little longer. So if you are following along with me, creating the work cell, and you come across this kind of issue that we saw before with the non-pre-grouping robot picking up with an offset, this is really an issue with RoboGuide, not able to follow the tracking frame properly. In essence, I didn't do anything different by moving the position of the user tool number 1 on robot number 2. What you need to do is just restart RoboGuide and run the simulation again. We can also look at the vision runtime. You just select iRVision, vision runtime. You're going to see that the vision process is finding the part every time, even when the part is rotated or with an offset on the Y. And this is an important verification that you need to do to verify that the vision system doesn't reject any parts. In conclusion, what we saw here is one of the many applications where you can use iRPickTool. As we saw at the beginning, depending on the configuration of the conveyor's layout, one of the robots might not be able to reach the outfit conveyor. In such a case, you can use pre-grouping. Also, you can use pre-grouping when you see an opportunity to reduce the cycle time. One of the disadvantages I see in this configuration is that you need to have a constant flow of product if your product has peaks and valleys, and with this I mean that you don't have a constant flow. The pre-grouping robot is not going to be able to complete the virtual tray during the valleys, and the non-pre-grouping robot obviously is not going to pick it up. So in this case, you're going to have a significant overflow of parts running out of the infeed conveyor, and your customer might find this not acceptable. With this, I conclude the presentation for this video. I'm going to leave the link to the work cell on the description below, and thank you for watching.